What I'm here to talk about today is our Azure Data Factory, and specifically looking at how Data Factory can be used to create data pipelines for your ETL or ELT processes, depending on what you need to do. And then specifically looking at a feature of Azure Data Factory called mapping data flows. And mapping data flows will allow us to do some of those advanced transforms that typically we would write code for, or we would write various scripts for, but mapping data flows allows us to do that from a UI perspective. And what's really nice about them is the fact that they're all backed by a Spark engine. So effectively, behind the scenes, they run on Azure Databricks. So they're very scalable, very performant, very, very useful from that perspective. So what I'm going to do here today is go through the product, talk about the ideas behind Data Factory and specifically mapping data flows, and then we'll spend some time really just looking at the product itself and looking at an example pipeline that we might be using to kind of move data through an entire pipeline, through a life cycle, if you will, in kind of the modern data warehouse environment. So that's the plan for the next hour. So this shouldn't be news to anybody that's on this particular webinar. If you're here because you're a data person, you've been involved with data. Mikhail mentioned this earlier, said that I've worked with SQL Server forever. To give you an idea what he means by that, number one, I'm old, but number two, the very first version of SQL Server that I ever worked with was installed on OS/2 as the operating system because Windows didn't support it, and Windows NT wasn't a product yet at this time. So that gives you an idea of how long I've been doing this. And the reason that that's relevant is because while it's always been important from a data perspective, the data has always been important to organizations. Today, that is really important. Almost every organization in the world, now these statistics that come from Forbes magazine, they say that 80% of business requires data integration, and I just think that's a low number. I think 100% of businesses, whether they want to admit it or not, require some form of data integration in some form or another. In my role at Microsoft, I'm very fortunate in that I work with very large organizations, and specifically I work in our Las Vegas market, which means that I spend a lot of time in our gaming and hospitality world. And from that perspective and from those organizations, the data is the most important thing. It is their currency from that standpoint. And because of all the regulatory requirements and everything else that happen in this space, there's a lot of hybrid integration that must occur. There's some data that must be on premises. There's some data that they can move to the cloud, but all of their data requires that it be combined whenever they're analyzing that data and working with that data. So from that perspective, Data Factory becomes an incredibly important tool for them, because they need to be able to quickly get their data from their on-prem sources into the cloud, and they need to be able to work with it and analyze it and deal with it from that perspective. And Data Factory is the tool that they've chosen in order to do that. Well, when we think about Data Factory and we think about what it is supposed to do from this perspective, this picture that's kind of going on right now really does drive a very good description of what's happening. So your organization has data. Now, you might have data from just one single application, but you probably have data from multiple applications, multiple types of data, and you need to be able to analyze that data. And in order to do that, what you have to do is find a way to combine that data, put it into a format that you can actually use, and then get that data out to the consumer of it, whatever that consumer might be. You know, back in the old days when I first got started in all of this stuff, that bottleneck box that's here was usually our enterprise data warehouse. And we had to find some mechanism to build a common data model that gave us the ability to query all of this data in a single database across all of these things. Today, that isn't necessarily true because most of our analysis tools have the ability to reach out across multiple sources and everything else. But the fact of the matter is we have to find some mechanism to bring the data together, to aggregate the data, and to work with it. And that's really what Data Factory is all about. And then the other side of this coin is now that we've figured out how to integrate the data, move it together, put it into a common form, we have to figure out some mechanism to actually analyze the data, use the data, work with the data. Microsoft's answer to that problem today is a single platform that we call Azure Synapse or Synapse Analytics. But the fact is it can be any tool that's out there. And there are hundreds of tools that organizations use today, if not thousands, that are available for people. So when we think about all of these problems and we think about what we have to accomplish here with all of this, this is really what it comes down to. We have 4 pillars that we think about, and these pillars are what Data Factory have been designed to meet from this perspective. Now, I always dislike this particular phrase and this term, but the left-hand side here, when we talk about easy to use. Easy is obviously a relative term, right? If you are an old school data professional like I am, some of the concepts and techniques might be a little bit different. If you're coming over from a tool like SQL Server Integration Services or, you know, some of the other tools, you know, like Spotfire or, you know, other ETL type of tools that are used, Data Factory is different. And because it's different, you may not find it to be quote unquote easy to use. But the idea here is that we want to simplify it as much as possible. We want to make the flows as natural as possible throughout it. And one of the key tenets is we want to do it with as little code as possible from this perspective. So we actually represent Data Factory as a code-free ETL, ELT tool. Now, as you'll see when I get in a little bit to the product itself, we do have the mechanism to write code here as we need to and move through it. But the idea, the target that we shoot for is that everything be as code-free as possible. We also, one of the key tenets of Data Factory is that we have the ability to lift and shift our SSIS, SQL Server Integration Services, packages in as few clicks as possible. The idea being that we should be able to move our on-prem SQL Server Integration Services environment into Azure with little to no change in the operation of those packages. That's a key driver for Data Factory. The other key driver in Data Factory is that we are tightly integrated with our configuration and deployment tools, CI/CD, DevOps, DataOps. All of these things are built in to Data Factory. And I'll get into a little bit of that as well as we go through this. The other side of this, the other tenet that we have here, or pillar, if you will, for all of this, is we want to make it cost effective. Notice that I didn't say cheap. Notice that I didn't say inexpensive. What I said was cost effective. The idea here is that the model around how we actually charge people for using Data Factory, it's pay as you go. It's serverless, so you don't have to have a big cluster stood up in order to support this. You don't have to have a big virtual machine stood up in order to support this. And it scales on demand for this. Now, you have control over the scalability, but it does scale on demand for that. So the idea is you don't have a massive infrastructure that you have to worry about in order to put this all together. Another pillar that we have here is that it's a very powerful tool for this. We've got more than 90 built-in connectors. We can orchestrate data at a massive scale. It's very intelligent. It's very, very, how shall we say, AI-based whenever we look at how the system manages itself. It makes use of a lot of optimizations that are built in and AI optimized from this perspective. So there's not a lot of work that an administrator has to do in order to run Data Factory, but at the same time, we give you the ability to control it to meet your specific needs. So we give you the ability, but we don't require you to use that. So again, at a very high level, when we think of Data Factory, these are the 4 pillars that we really think of in terms of why we've done some of the things that we've done in order to do that. So if we look at the overall kind of architecture, if you will, for Data Factory, it really does fit very well into the modern data architecture, the modern data warehousing kind of plan, architecture, and everything else. And the nice thing about it is it's not a single person focused tool or a single role tool. It's a tool that is designed to meet the needs of the data engineer, the data scientist, the data wrangler, if you will, the citizen integrator, which is an interesting term. And what we mean by citizen integrator here is basically a user that sits at the business and they want to be able to use a tool to move data around. They should also be able to use a tool like Data Factory. It's not something that has to be a very highly trained, specialized ETL engineer. We should be able to use it from the business perspective as, kind of a typical, non-techie role, if you will. So these are the 3 main audiences whenever we think of Data Factory. And then if we go from left to right on this particular diagram here, when we think of how we work with Data Factory, we have multiple data sources, different types of data, be they on-prem data, be they cloud data. And I don't mean just Microsoft's cloud. I'm also talking about Amazon. I'm talking about Google, talking to a certain degree about Oracle Cloud even. And we also need the ability to work directly with, SaaS data, software as a service. So specifically things like Salesforce, SAP, other tools that are available in the cloud. So from an ingest perspective, we have, more than 90 built-in connectors that connect to all of these different sources. So from an ingest perspective, we should be able to easily connect up to a data source and collect that particular data. And then once we get it into the Data Factory environment, we should be able to do the prepare the data, transform the data, enrich the data, run models against the data, do all of the things that we want to do. And in order to do that, we give you the ability to work specifically in either a code-free environment or a code-centric environment for this. Data Factory also gives us the ability to orchestrate that as far as a pipeline and monitor that across the board, with, of course, Data Lake being the center of all of this. And then moving on to the right side here, looking at the serve layer and the visualize layer, working with tools like Azure Synapse, which, by the way, Azure Synapse Analytics incorporates Data Factory as part of its overall environment. When you say Azure Synapse, you're also talking about Data Factory as a component of that. And then finally, of course, working with the visualize layer, Microsoft's tool is Power BI, but we have the ability to connect to all of these different data sources. So if I kind of change things a little bit and put some product names associated with that, we really do think of Data Factory as the ability to work with all of these different things, be it Databricks, be it HD Insight, be it Azure Machine Learning. However we want to do this, Data Factory has the ability to work with all of these tools. The diagram itself doesn't change, just the technologies that we might put into place in order to do some of this stuff will actually come into play here. So this will be kind of the last architecture slide that I have, and then we'll sort of move into some of the more deeper details. But at a very high level, when we think about orchestration inside of Data Factory, everything that happens at the behest of a trigger. And that trigger can either be a scheduled trigger, it could be an on-demand trigger, it could be a reactive trigger waiting for something to happen, some event or something along those lines. And then what that trigger does is it executes a pipeline. And the pipeline is the core component of Data Factory. And the pipelines consist of various activities, and those activities perform various functions. So if we think about it from the way that we think of traditional ETL or ELT tooling, like SQL Server Integration Services, the Data Factory pipeline would represent our control flow environment. So if you're building an SSIS package, for example, the pipeline would represent the control file or the control flow, and then the data flow represents sort of one of the activities that might be inside of that. And then these activities either execute in the context of a cloud function, the Azure integration runtime, that's entirely and completely managed by Microsoft, or it executes in the context of a self-hosted runtime that the organization that you would control and set up. And the idea being that the integration runtime is the execution environment for that. If you relate this back to SSIS, for example, this is where the agent executing the DTSX package is running in order to perform the activity that's represented. And then, of course, we have the linked service, which is how we connect to the data set, which is the definition of the data that we're working with, and how we kind of move these things all together. So this is really kind of the orchestration model that we work with inside of Data Factory. If we start drilling into the activities, one of the activities might be a transformation of the data. We want to transform the data from one state to another. We want to enhance the data. We want to work with the data, things like that. And that's where this concept of a mapping data flow comes into play. Inside of Data Factory, we have two types of transformation engines, if you will. One of them is called Wrangling data flow, and that is effectively, if you've ever used either Excel's Power Query or you've used Microsoft's Power BI and the Power Query capabilities built into that, Wrangling data flows is effectively that. It is effectively Power Query, but built into the Data Factory environment. We have mapping data flows, and mapping data flows are effectively your object-based transformation flow. And mapping data flows is kind of what I'm going to focus on for the rest of this time here, about probably the next 20 minutes or so in the presentation. And the idea behind mapping data flows is they allow us to create a visual ETL, extract, transform, load, or ELT, extract, load, transform process in a relatively intuitive environment. In other words, we should be able to look at the boxes and figure out exactly what's happening here. The idea behind mapping data flows is that we have a user experience that allows you to spend less time designing and testing everything in the data flows themselves and more time dealing with, constructing, and working, in concert with the business logic that allows us to perform these transforms or requires us to transform these. As I said earlier, the concept of data flows, specifically mapping data flows, is that we're providing you a visual environment to perform the transform, but on the back end, the actual execution of this is on a Spark cluster. It runs Azure Databricks in the back end, and it allows us to create very, very scalable and very quick transform of the data for this. I kind of mentioned all this earlier, but just to kind of reiterate here, the idea behind the Synapse platform, the idea behind what we're doing with all of these things is giving you the ability to choose how you're going to work with your data here. By default, we work with it in our environment. We spin out to the Azure Databricks environment, and you visually transform everything. You don't write any code, and the end result is you have kind of a data pipeline that you've constructed purely from a visual perspective. But within the Synapse environment, you also have the ability to use any of these other tools that are built in to kind of perform that, or you can use Data Factory to kind of orchestrate the whole thing. And I will sort of, when I kind of get into the product, I'll demonstrate exactly that, how we can use Data Factory to orchestrate an entire end-to-end pipeline using most of these tools that we have here. But what I want to do is really focus on the actual transform component here. And in order to do that, we're going to kind of really dig into what mapping data flows is all about. I've said it a couple of times, but you might get the impression that I really want to get this point across. The whole point of mapping data flows is that we provide code-free data transformation, and we do it at scale. The whole idea of data cleansing, data validation, data aggregation, rather than requiring the engineer to know Spark, to know the code, know Python, Scala, whatever language you're going to use for this, in order to perform these tasks. And by the way, data engineers today in the modern data warehousing world do know these tasks. I mean, they're definitely very good at the Scala code or the Python code or whatever code base they're going to use in order to do this. But the idea here is we want to allow the data wrangler, the data engineer, if you will, to focus on the logic of what you're doing as opposed to the code of what you're doing here. And that's the idea. We give you a visual environment in order to create these transforms and work with these things. You don't have to worry about managing your cluster. You don't have to worry about, does this work in Spark or whatever. You just worry about what it is that you're trying to accomplish and let us figure out the best way to execute that transformation. So again, mapping data flows, code-free data transformation at scale, serverless, entirely managed by Microsoft from the standpoint of the Data Factory manages the provisioning of the cluster, manages the transform of the code into the Spark environment to execute it. It's a very resilient infrastructure, the ability to be geo-distributed if you need to. A lot of different capabilities that are built into the back end of this. And it's one activity inside of a Data Factory pipeline. So the nice thing about these transforms is that they execute in the context of a pipeline activity, if you remember that earlier picture that I put up on the screen here for this. Data flows gives us the ability to write all of these transforms and work in this particular environment. Now, there are literally hundreds of thousands of use cases where data flow can be very useful. But I'm just going to give you a couple of really common scenarios, common examples, and then I'll spend a little bit of time here, and then I'll jump into the actual product and show you a very specific example of where Data Factory and data flow can come into play here. One of the big challenges that we have in the data engineer's life cycle and the things that we have to work with is the fact that slowly changing dimensions are a thing. There's something that we have to deal with. There's something that we have to work with. And they're especially true today as more and more organizations move away from the hardened enterprise data warehouse into a more agile data repository, data lake, modern data warehouse where things are changing much more rapidly on us. These slowly changing dimensions become a real problem. And mapping data flows was designed very specifically to deal with that particular problem, giving us the ability to do things like work with a type 1 slowly changing dimension or a type 2 slowly changing dimension where we either replace the data in the descriptor or we add a new record for it and set a time window and all of these things. These are all processes that could really vex a data engineer, that can really throw a wrench into their process, if you will. And Data Factory is designed to simplify that particular process. And an example that I have here on the screen just is one way of looking at the slowly changing dimension problem. Another problem that mapping data flows and Data Factory are designed to deal with, and these are very big tenets in the design, is validating our data and deduplicating our data, making sure that we have the ability to do things like fuzzy match the data, joining on a soundex, for example. So being able to handle all of these things and look at, is this data really this data? And I have to tell you, in my particular experience working with the customers that I work with, one of the biggest problems that they have from a data perspective is, and I'll specifically think about my gaming customers, where they have the loyalty programs, where especially in Las Vegas, if you've ever made a trip to the U.S. and gone to Las Vegas, all of the casinos have their own loyalty cards, and the loyalty the loyalty cards are used for all sorts of different advantages for patrons, for customers, and everything. And so one of the challenges that they have is that a lot of times customers will come to Vegas, they'll sign up for a card, and then they won't come back for another year. They won't bring the card that they signed up for, so they'll sign up with a new one. And then now how do we determine, is this a new customer or is this somebody that we've seen before? And this particular process, this particular transform that's here on the screen is one way that they deal with that, by running all of the new applications for loyalty cards against their existing data and doing fuzzy lookups and fuzzy matches to try and determine, are these things the same? It's a very big thing in my in my world. And of course, another example is something that everybody does in one way or another, loading the facts, the fact data, the actual raw data into a data warehouse. The ability to create a very nicely laid out process in order to do that. Now, I mentioned earlier that we are code-free data transform. Well, code-free doesn't mean that you never write code. Code-free means you write as little of code as possible for that. But there might be a need for you to enhance your data with some sort of coding or some sort of scripting or ability to do that. And so inside of Mapping Data Flows, we provide for you an expression builder, an expression language that allows us to put this as part of the transformation process and write scripting code, but do it from the perspective of a visual expression builder like this here. And what's really nice about this tool, and I'll show this whenever I get into it, but what's really nice is that we have the ability to debug our environment right from within the builder itself. So you can kind of see here, we can write our script up here in the upper right-hand corner, and then we have the ability to see in real time the output of that script. We don't have to run the entire pipeline in order to get to this point so that we can see this. And I'm telling you, the first few times that I experienced this when I was developing in this environment, it really impressed me, the ability to do this right here. It really saved a lot of time for all of that. I won't spend a lot of time talking about the expression language, but just know that within data flows, we have a very specific expression scripting language that gives us all of these built-in functions, the nice, hard, typed data types, data sets, data schemas, schema binding, the ability to perform all these different functions and everything. And then on the back end, what we do is we translate everything that you do in this expression language into Spark code that works on the data, iterates over the data, and deals with it from that perspective. All right, I'm sure that you're tired of hearing me talk at this point and display some slides. So let me go ahead and get right into kind of the product itself here at this particular point. So kind of first things first, if you've not seen Azure, Microsoft Azure, and you've not seen the Azure Data Factory, this screen that I'm showing you right now, and I know that a lot of the text is really small. Don't worry, as I go through the demo, I will highlight the important areas that I'm talking about and make them larger so that you can actually see that. But this is the main screen for our Data Factory environment. And you can see here right from the screen, what it does is it gives us an overall view of all of the data factories and pipelines and activities that are running in our environment. It kind of tells us everything that's happening and gives us a lot of the statistics that we need from a management perspective right away. So if I look at this, for example, what I can see is that, if you look at my environment here, I've actually had, from a pipeline perspective, none of my pipelines have succeeded recently. But from an activity perspective, and remember the hierarchy here, a pipeline consists of multiple activities. And so what we see here is that I've had 2 activities that succeeded, but one of them that failed. Now, from a trigger perspective, which runs the pipeline, my trigger succeeded. So that means that the pipeline was executed, but then it failed at some point in the execution there. So I have this screen right here that gives me all of this information sort of as necessary that I work with. Now, once I've kind of seen the high order, I know what my data factory looks like, then what I can do is I can go into my detailed monitoring or my authoring screen here for everything. When I click this button, it brings me to this environment, which is our data factory user interface. Now, what we try to do is we try to make this a relatively straightforward tool that can work very easily from the browser. Now, if you're using Azure Synapse, you would be using the Synapse Studio in this particular case. I'm not using Synapse here. I'm using the standard data factory environment. But the idea behind Synapse is the tooling is the same here for that. But depending on what I might want to do, if I'm just starting out, I can, from right here, I can look at, various instructional videos on how to do things. And then right here within the tool itself, we have our tutorials that are built in, how to do things, how to transform data, how to execute control flow, how to transform data in the Databricks environment. If I just want to move my SSIS packages, I have that right here. I can learn how to do these kinds of things. And then right here at the top, depending on what I want to do I want to create a pipeline? Do I want to create a data flow? Do I want to use a template? Do I want to use a wizard for that? All of these things are right here, relatively easily accessible right here across the top. Over on the left-hand side here, these are kind of our very specific tools that we can actually use here. So if you look at the pencil tool, for example, that's where I author and work with my pipelines and my data flows and overall. And then the little gauge there, that's where I go to monitor everything that happens in my data factory environment. And then the little toolbox there is where I go to configure all of the various settings for that. But if I go here to my authoring tool and look at that environment here, what I can see right away is that I have, in this particular environment, I've got, and hopefully it scrolls there for you. There we go. I've got 5 pipelines that I have in my environment. I've got 22 data sets that I'm working with in my environment. And I have 3 data flows that I'm working with. And I did not create any templates or use any templates in my environment here for that. And then also, if I look at the kind of the top part of the screen here, what I can see is that I'm directly integrated with my GitHub environment, and I'm working with the master branch. And for all of you that are, CI/CD, you're into the DevOps or data ops world, you're probably screaming at the fact that I'm working in the master branch here. But this just happens to be my demo environment, and I didn't want to complicate it too much there. But you see all of that right from the screen here. And then if I take a look at my pipeline environment, and of course, if we think about a pipeline that's relatively simplistic and very relevant for our times today, I have a pipeline right here that says, new COVID data. So I have a pipeline that executes that on a daily basis, goes out, collects all of the new data related to the COVID situation, and then puts that into a data store for me. It's a very, very simplistic pipeline. If I click on it here and look at it, what we actually see is two parallel branches, and all they're basically doing are executing a copy data wizard and a stored procedure. Again, very simplistic data. And then if I look at it, all I'm really doing, from the copy data perspective, I can look at that activity and see my source data. And in this case here, the source data is a web service. And it's a web service that has a specific URL associated with it. And it's going to be a JSON file that responds from that. And so I go use my copy data wizard to get this particular data that looks like this. So here's the schema of that data. And then I see all my data types. I see the, the column name for that. So basically what I'm doing is I'm parsing that JSON file. I've got all of the data. And then if I look at my pipeline, that was my source data. And then what I do with that data is I put it into a staging table inside of a data warehouse. And so if you look at this particular layout here, my sync data set, the data set that I'm writing to, happens to be a table in a SQL database. And prior to executing the copy activity, I'm running a truncate table command here for that. So it empties the table, moves all of the new data into the staging table. And then, very simply, as I see the mapping of that information here, I could see that, on the left-hand side, I see my source data. And then on the right-hand side here, I see the column in my database, the table that I'm pointing to, and how it's just going to be mapped directly across. So one-to-one mapping in this particular case with no transforms involved here. It's just a very simple copy activity. And then what I do is after it's performed that copy activity, then I execute a stored procedure, which happens to be inside of my database. And all it's doing basically is moving the data from that staging table into the actual main data table, the fact table, the dimension tables, so forth and so on. So it's a very simplistic process with a copy data wizard and a stored procedure. And I have two separate branches, one that gets data at an aggregate US level and one that gets data at a county level. So much more data involved here. But there are two branches and they execute in parallel. So very, very simple transform for that. And Data Factory allowed me to create this and work with this data in this particular format. So again, that was a very simplistic pipeline that showed you the pipeline itself and then the activities within that pipeline. And in this case, two parallel branches with each branch having two very simple activities that are run. Another example is, and this will be the last one that I go through here. I'm going to leave a little bit of time at the end for any questions. But another example is a little bit more of it's still a relatively simple pipeline, but it does give us a little bit more of an end-to-end process here. So there are several activities in this particular pipeline. And if I walk through each of them here, I'll kind of zoom in a little bit for you. But the very first activity here is a lookup. And what that lookup does is looks at my existing database and figures out what the high water mark in that database is. So what it's doing in this particular case, it's querying the database, looking at the last record, looking at the date of that last record, and then saving that date. And then it's setting a variable at the package level or at the control flow level for this with that particular date. Then I have that same copy activity that we saw earlier, but this one is a little bit more involved in that it's using some dynamic content here to basically build my query that I go against the web service for that, using the last date variable as part of my parameter for that. So it gets the data, queries all the data since the last date, and then now that I have that data, now I need to transform that data. And here's an example of that data flow where I'm actually using this activity to transform the data. So if I click into this, what it does is it brings me into my data flow environment here. And the data flow, again, it's a relatively simple transformation, but what I've done is I've taken the data that I received as the output from my web service call, and that's this activity here. I've looked at the data and notice that it has 25 columns associated with it here. And then what I'm going to do is I'm going to remove some of those columns because I don't need all of the columns. So my output flows from this environment to this one where I now only have 21 columns because what I've done is I've removed some of the columns. I haven't mapped some of them in the list here. So as we kind of saw earlier where we kind of had some of those things that were direct mapping. Now what we're doing is we're ignoring some of my columns. And then once we've removed some of those columns, now I'm going to add a column by combining a couple of values for that. So I've started off with the overall output of the web service call. I've removed some columns, and then I've used my scripting language here to actually create an existing column by concatenating two of the columns that were out there. So you can see here a very simple expression builder. I'm concatenating my latitude and my longitude, adding a comma into that and making it available to me. And this is my script builder that shows me how relatively straightforward it was in order to do that. And then now that I've done that, now I've got 22 columns in my data. So now let's go ahead and output that back to my database for that. So the transform is relatively straightforward, but done from a visual perspective here. And if I wanted to add additional transforms, if I wanted to do something new, if I just click here, these are all of the things that I could do, at this particular case for that. And I know I'm getting short on time here, so I'll sort of finish up with this. But now that my pipeline has run and it's called my mapping data flow activity, now that I've gone through this, now I can go back to my pipeline here, and my next item is running a stored procedure that takes the output of my data flow, which transformed my data, and moves it into my main database. And then once I've done that, I can add a couple of other activities, which are just Databricks notebooks here, which are very specific Spark activities, specifically around running some predictions against the data. And in this particular case, it's crime data. So there's two categories of crimes that we're looking to predict, one of which is The category of sex crimes, the idea is, being an indicator for human trafficking, number one. And then number two, violent crimes, so the ability to work with that. So at a very high level, and, I know I kind of talked too long at the beginning, so I ran out of a little bit of time for in my demo environment here. But you kind of get an idea now of Data Factory and the concept of creating a data flow and sort of moving in a pipeline from our various data sources, bringing them together and utilizing the tools in order to create an overall pipeline that accomplishes a specific task from that. So with that, I'll go ahead and open it up to questions. I think we have about 4 minutes left. If anybody has any questions, feel free to put them out there.
First question is from Mario. Is it possible to lift and shift a SSIS package that makes use of SQL linked service across to ADF? So I think he just wants to pick up an SSIS package, put it in ADF, and not to have to change any link server connections.
Yeah, so that's actually a great question. And the answer is yes, it's possible, but it's not a simple just click a button and we magically, do the easy button, everything for you. What you actually have to do in that particular scenario is recreate the linked service as a data source inside of your Data Factory environment. There's actually a really good tutorial on that. If I go back to this screen right here and I drill into this tutorial, the lift and shift, there is a section in this documentation that's very specific about the integration setup for the linked services. It's actually a little bit farther down here. There we go. The runtime. There we go. The linked service right here. So this is where we would modify that linked service, if you will, that you had, the linked server, and recreate it here in the Data Factory environment. So again, how I got to this location that talked about this is from within the Data Factory main screen here, going right here to the tutorial, and then scrolling down to the section of about linked services.
There is a lift and shift for the SSIS package, but is there a simple package migrator that gives us a native Data Factory flow? If we have a simple SSIS package, can we generate the flow in native flow, so to say?
Well, Mikhail, I love that question. I love that question, and I wish I loved my answer as much as I love the question. But no, we do not have a simple tool that transforms the SSIS package into a Data Factory pipeline. And I would give my left arm for that capability for the number of times that my customers have asked about that.
Is there any kind of scenario at all or a feature in the Data Factory that where it makes sense to use Data Factory with an on-premises source and an on-premises destination?
The answer is I'll give you a qualified opinion here. This is not an official Microsoft answer. It's an opinion from Ted Malone. But I would answer that, yes, absolutely, primarily because what you're going to have in the Data Factory environment is the ability to highly scale your transformation process, your pipeline, and make use of the cloud resources in order to do that. So I'll give you one really good example of exactly that. One of my customers utilizes an on-premises system for all of their financial reporting. And due to the nature of the way that the data is collected, they cannot move that data into the cloud. It must live on premises. But because they have so many properties all over the world, it is not cost effective for them to manage the infrastructure on-prem in order to handle all of the necessary transforms and work from this data. This data set is more than 1 billion, that's with a B, bravo, rows of data. So what they do is they connect to the data on-prem. They have a very big pipe that allows them to get to Azure. So they run all of their transforms inside of Data Factory in the cloud, but push the data back on-prem where it's at. And the idea there is they could take advantage of all of the cloud scale without having to buy the hardware necessary to support that.
So, question from Sunil, who has actually won the award for the most questions asked on tonight's presentation. Does ADF support streaming data? And also another follow-up from him. Also, is CDC functionality included in ADF, or do you have to use a different tool or mechanism implemented in a database?
Both fantastic questions. The first one is real easy to answer in the sense that, yes, we do support that within Data Factory as a native function. Now, from a CDC perspective, as it exists today, Data Factory does not have CDC change data capture capabilities. However, that is a roadmap item that don't be surprised if one day, very soon, magically you see the fact that Data Factory has change data capture capabilities built in, not only for SQL Server, but also for other databases from a relational perspective.
So this is also a two-part question, and it starts with, do on-premises self-hosted runtimes have a bandwidth capacity limit? And the second part, since we know the answer is yes, and is there anything we can do to get around that?
Yeah, so that's excellent question again. Boy, I'm going to have to do these webinars more often because these are fantastic questions. But so yes, the on-prem self-hosted integration runtime is relatively limited in its capacity, its bandwidth for the ability to connect to the data. How we get around that, how we increase that capacity, is by horizontally scaling the integration runtime. You can have up to 4 integration runtimes in a single connection. So what you can actually do is create 4 on-prem runtimes and connect to them from a single data flow connection, and you will aggregate the processing capability and the bandwidth capability. But of course, at that point, you're going to be limited by the pipe that you're connected to Azure. In that particular case, I would recommend that you have a very large express route connection into Azure that allows you to maximize that bandwidth and the data connectivity.
Is there a good way to understand the cost of what you're incurring by utilizing the Databricks cluster that's being used under the covers of ADF?
Another very great question, and one that I'm chuckling because it's a very hard question to answer. So what I tell my customers is that there's no way for me to accurately estimate what their cost is going to end up being from a Databricks perspective on the back end for this without actually running the data pipeline and getting a representative sample and then just extrapolating from that sample. I wish there was a better answer for that, but it's really difficult to come up with an accurate estimate without really understanding how often the compute is going to be utilized, how much data is going to flow through it, and the only way to do that is to really take a representative sample, run it, collect the data, and then extrapolate from that, unfortunately.
And we have a question again from Sonal. Does ADF include address standardization and or a validation tool? And I'm guessing, since I'm Swedish, we're talking about zip code validation, phone number validation, and things like that.
So the direct answer to that question is it's not built in to Data Factory. However, there are many open source tools and even commercial tools that accomplish that task, that can be very straightforward to integrate into a data pipeline. I'll give an example. I have one of my customers, they have this problem where they want to make sure that everything is standardized, and they've hired a third party in order to do that. And so what we do as part of the pipeline orchestration is we push the data to that third party. They perform that activity and then push it back to the pipeline, and it's just part of the pipeline process. Now, clearly, that's an inefficient way to do it, but for this particular scenario, it works well. But there are a number of tools that work well in conjunction with Databricks that perform those activities.
Can you or should you be careful of what you change the data types to from the data source from a performance perspective? In other words, does ADF internally consume more memory on the flow when you use different data types in the same way that SSIS does?
Yeah, so another fantastic question, by the way. And the direct answer is yes, we definitely want to look at those data types. And I'll give a very specific example. Working with date data, it's much easier to work with date data as a string throughout the pipeline as much as possible, converting it to the actual high fidelity date type closest to the end of the pipeline as possible, primarily because A, it helps us with error detection and everything, and B, there are some date types that, from some data sources that can be relatively hard to deal with. A perfect example of that is how Teradata, for example, manages date data. It can consume extra resources in Data Factory because of the translation of the data types. So what I like to do is I like to treat my date types as string as long as possible throughout the process before converting it back to the high fidelity date. But yes, Data Factory is no different than SSIS in that regard. We definitely have to think about some of those things.
And Brent is asking if there is a reason in your example that you chose a stored procedure to do the final data move rather than building that also within the pipeline.
Yeah, a great question. Man, I'm telling you, I really love these questions. Yeah, but the reason does not make a lot of technical sense. It's purely just my own bias showing. Because I'm an old school data person, I like to transform the data as close to the database as possible. So that's why I choose stored procedures. A modern data architect would probably look at my pipeline and do everything that they could to take that logic and put it into the pipeline itself. But I'm just an old school architect. I just like having my logic as close to the data as possible.
So we've got a question from Harish here, which you could take as two different meanings. So I'm going to try and interpret it for you. Is it possible to share the source code? I'm suspecting he's not talking about ADF Git integration. I'm suspecting he's wanting to see if you can get hold of your demo source code.
So So I'll answer both the dimensions of that question. So the first one is absolutely, I'm more than happy to share my source code. It's on a Git repository. I will send you folks the link to my Git environment, and you can pass it along. Yeah, the second part of that answer is if you're talking about the Spark source code that is executed as part of the mapping data flow, the answer today is no, we don't have the ability to drill into that, but that is a very high priority item on the roadmap to be able to click into your transform and see the Spark code that's generated.
We have a question from Andy that I'm going to change to a statement. Is ADF and orchestration in Synapse Analytics the same code base? And you've answered that the ADF is running on Data Spark, and the Synapse Analytics, isn't that the code base of the open source? Same thing. So they have different code bases. The ADF runs on the Microsoft native Data Spark clusters, right?
Yeah, so the answer from a code base perspective is that Data Factory, the code, Data Factory itself, is exactly the same between what I'm showing you here in this environment and what would be inside of Synapse Studio. On the back end, it's the exact same code. There's no difference. Now, what you just answered is a slightly nuanced component of that, in that the Spark environment inside of Synapse, the actual Spark integration, is open source Spark, not Azure Databricks. However, whenever you're executing mapping data flows inside of the Synapse environment, it does run on Azure Databricks, even though you're in the Synapse environment.
And we have time for one more question, and that is, what about egress cost? So the cost for an on-prem source to an on-prem sink, like not importing data to Azure, but rather taking it back again to on-premises.
Yeah, and that's a really good call out there, and that's actually the reason that I suggested that if you're going to do that, you want to use a service in Azure called ExpressRoute, because in that particular case, the ExpressRoute connection would absorb those egress costs. That you would not be paying any data egress out of Azure to go back to on-prem.
Great stuff. So I was going to close off the session now. However, Gasper's actually come in with a really good question. So I'm going to see if I can be cheeky and slip it in. How many self-hosted Azure integration runtimes can one install to ingest the data from one on-premise SQL server?
Yeah, boy, that is a great question. And I believe, and this actually is something that would require a little bit of research on my part, because I'm not sure that the answer I'm about to give is 100% accurate. But I believe the number is 4 per pipeline. But I will have to research that and get back to you on it.
Okay, thank you very much, Ted. It's been brilliant. The engagement from the audience has been fantastic too, so I think everyone's loved it. We've now come to the end of the session. I can only say thank you very much for joining us, and hopefully we can have you back again sometime soon.
Yeah, I would love it. Thank you very much. Great questions, everybody.